Alright, let's go.
Alright. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Uh, the Today we're gonna present about electrical machine and drive. Okay. By the way, my name is Shafiq Daniel bin Rusli. And then another two is my team member, which is Muhammad Aiman bin Zulkifli and Nur Anissa Akmalia binti Syamsul. Okay. This is a introduction for uh, this transformer. The primary winding and secondary winding of a typical transformer are depicted in figure 1. The power input winding, which is connected to the AC power source, is the principal winding. The primary winding is physically and electrically insulated from the secondary winding, which is connected to the load. Typically, the ratios between the primary and secondary windings is in a transformer are predetermined. Although transformers are frequently used to step up or step down voltage and currents, they can also be utilized to isolate electrical system. The transformers N1, N2, or NP and S turn ratio relate the voltage and current flowing through the secondary to the current voltage and current flowing through the primary. The ratio of primary to secondary current is equal to N2 N1, which is the inverse of the turn ratio. Whereas the ratio of primary to secondary voltage is equal to N1 N2, which is secondary voltage. Uh, Next, I will pass to my team member, which is Muhammad Aiman bin Zulkifli.
Okay, hello. Hi, my name is Muhammad Aiman. Okay, today I want to explain about the calculation of lab 1. Okay, for the first experiment, we use step up transformer with no loads. Okay, so we use 5 voltage level, which is 10 volt, 30 volt, 50 volt, 70 volt, and 100 volt. So V1 is measured from the circuit. So we get for voltage level for 10 volt for V1 is 10.11 and V2 is 18.2. So the voltage ratio is we get 0.53. How to get the voltage ratio? We will use V1 divided by V2. So that's the formula to get the voltage ratio. So move to next, 30 volt voltage level. We get for V1 30.9, the V2 58.2. So we calculate and then we calculate for the voltage ratio and we get 0.53. For the next is 50 volt voltage level. We measure, we get 50.9 and V2 96.6. And then the voltage ratio for the 50 voltage level is 0.526. 70 voltage level, we get the V1 70.1 and the V2 133.2. So the voltage ratio is 0.526. And the last one, 100 voltage level. For the V1, we get 100.4 and the V2 191.5. And the voltage ratio is 0.524. So we move to the next, the analysis of the experiment 1. I will pass to Nur Anissa Kemalia.
Okay, based on experiment 1, we use a step-up transformer without a load connected in accordance with the instruction on lab sheet. Once experiment 1 is complete, fill out all of the table 1. we use formula V1 over V2 to find the voltage ratio. So the total result of the calculation is roughly 0.52. The value V1 and V2 increase due to the experiment is step-up transformer. Can continue to experiment 2.
So for the next experiment is experiment 2, which is we use the same transformer, which is step up, but this experiment we need to use with a different 3 load. For the first load, we will use the load is 220 ohms. So at this experiment, we have to measure an extra, which is current 1 and current 2, and then the current ratio and the power efficiency. So for the first voltage level 10, we get the V1 is 10.43, I1 we get 0.2, V2 we get 18.85, and I2 we get 0.09. So for the voltage ratio 0.55 and the current ratio 0.45. So for the power efficiency we get 81.3. So how to get the power efficiency? We will use the formula, which is we need to find first the P in and P out. So how to get the P in P out? We will use P equal to IV. And then for the pin out, we will use current one uh, multiply with V1, and then we get the P in. So for the P2, P out, we will use the same formula. I multiply by V. So I2 multiply by V2, and then we get the P out. So we already have P in pin out. So P in divide by pin out times by 100%. So after we put the value on the formula, so we will get the power efficiency. So you guys can see at the power efficiency for the 10 volt is 81.3%. So for the next voltage level is 30. So the V1 get 30.3, the I1 is 0.57, V2 56.6, I2 0.26, water ratio 0.53, current ratio 0.456, and the power efficiency we get 85.4. So for the voltage level 50, V1 is we get 50.5, I1 0.91, V2 93.4, I2 0.43, voltage ratio 0.45, F54, current ratio 0.47, and the power efficiency 87.4. For 70 voltage level, V1 70.7, I1 1.26, V2 is 130.1, I2 0.6. Voltage ratio 0.543, and current ratio 0.47, and the last one power efficiency for 70 is 86.9. For the voltage level 100, V1 we get 100.5, I1 1.79, V2 185.2, I2 0.85, and voltage ratio 0.54, current ratio 0.47, and the power efficiency 87.3. So move to the analysis for experiment. Sorry. Another load. So the next load is we use 680 ohms. So we will use the same formula for power efficiency and voltage ratio, current ratio, and others. So for the 10 voltage variable is 10.05, I1 0.1, V2 18.72, I2 0.03. Voltage ratio is 0.56, current ratio 3.33, and the power efficiency 55.88. For the 30 voltage level, 30.3. For the V1, I2 0.24, V2 57.3, I2 0.09. Voltage ratio 0.53, current ratio 2.66, and power efficiency 70.91. 50 voltage level for the V1 50.4, I1 is 0.38, V2 94.9, I2 0.14. Voltage ratio 0.53, current ratio 2.71, and the power efficiency 69.92. For the 70, for the V1 70.4, I1 0.51, V2 133.8, I2 0.2, voltage ratio 0.53, current ratio 2.56, 2.55, power efficiency 74.53. Voltage level for the 100, V1 we get 99.9, I1 0.73, V2 188, I2 0.28. Voltage ratio 0.53, current ratio 2.6. And the power efficiency for the 100 voltage level is 72.2. So we move to the next load which is 1.5k ohm. For the voltage level 10, we get the V1 10.10, I1 0.08, V2 19.91, I2 we get the 0. Voltage ratio we get 0.507, and the current ratio we get the error because the when we measure at the I2, which is current output, we get the value is 0. So we consume that we get the 0 because of the losses when the transformer working. So we get the current ratio is error. So the power efficiency for voltage level 10 is 24.88%. 30 voltage level, V1 30.8, I1 is 0.16, V2 is 58.8, 58.0, I2 is 0.04. Voltage ratio is 0.53, current ratio is 4, and the power efficiency is 47.007%. For 50 voltage level, V1 we get 50.6, I1 we get 0.24, V2 95.6, I2 0.06, voltage ratio 0.53, current ratio 4, power efficiency 47.23%. So 70 voltage level, V1 get 70.7, I1 0.32, V2 133.8, I2 0.09, voltage ratio 0.53, current ratio 3.55, and power efficiency 53.226%. 100 voltage level, we get a V1 100.2, I1 0.47, V2 189.5, I2 0.13, voltage ratio 0.53, current ratio 0.61, and the power efficiency for voltage level 100 is 52.31%. So we move to the analysis for experiment 2.
For the experiment 2, same as experiment 1, but we use step up transformer, but we connect with 3 different load, which is 220 ohm, 680 ohm, and 1.5 kilo ohm. Each different load has different output voltage. As we can see on table 2, value of I1 for 220 ohm start from 0.2 to 1.26. This is because the value of resistance 220 ohm. Different for 680 load, value for current is 0.1 to 0.73. And for I2, start from 0.03 to 0.28. And the last one is 1.5 kilo ohm. Load start from 0.08 to 0.97. And for I2, 0.01 to 0.13. As we can see on the table 2, voltage ratio is roughly 0.53 to 0.56. But the difference for current ratio, the more load on transformer, it will gain higher current ratio.
So we move to the next experiment, which is experiment 3. We will use step down transformer with no load. So for the voltage level 10, V1 we get 10.47 and V2 5.33. Voltage ratio for this 1.96. For the voltage 30 volt, V1 we get 30.04, V2 16.05, and voltage ratio 1.87. And for 50 voltage level, V1 50.7, V2 26.7, and voltage ratio 1.89. For 70 voltage level, V1 70.6, V2 V2 36.7, voltage ratio 1.92. For the voltage level 100, 100.2, V2 52.8, and the voltage ratio 1.98. So we move to the analysis for experiment 3.
For analysis 3 is the same as experiment 1 because it used the step down method. The 3:1 ratio often equal the voltage ratio. We can ascertain that this is a step down transformer since N1 has a turn of 1000 and N2 has a turn of 500. There is not a single connection on the load in this installation. From the result of the acquired data, the average calculate ratio is 1.913, which is like the calculation based on the number of turn formula, which is 2. As a result, table 3 shows that as the number decreases, the voltage on the secondary winding decreases.
For the experiment 4, we use step down transformer with load. For the first load, we will use 220 ohm. For the voltage level 10, V1 we get 10.43, I1 0.03, V2 4.93, I2 0.03, voltage ratio 2.11, current ratio 1, and power efficiency 47.4. For the power efficiency formula, we will use same as the step up transformer, same formula. So next, voltage level 30 is V1 we get 30.07, I1 0.07, V2 15.58, I2 0.07, voltage ratio 1.93, current ratio 1, and power efficiency 51.93%, and 50 voltage level 50.1, I1 0.1, V2 25.87, I2 0.12, voltage ratio 1.93, current ratio 0.83, power efficiency 61.96. For the 70, V1 we get 70.2, I2 0.14, I1 0.14, V2 36.2, I2 0.17, voltage ratio 1.93, current ratio 0.82, power efficiency 62.61%. For the 100 voltage level, V1 we get 101.4, I1 0.18, V2 57.4, I2 0.24, voltage level 1.76, current ratio 0.75, power efficiency 90.3%. For the next load, which is 680 ohm, voltage level for 10, V1 we get 10.3, I1 we get 0.03, V2 5.22, I2 0. So the voltage ratio we get 1.97, and the current ratio for this voltage level, which is 10, is we get error because the losses when the transformer is working. So we get the current ratio is error. So the power efficiency we get 0 because the error from the losses. So and then the voltage level for the 30, V1 we get 30.7, I1 we get 0.05, V2 16.10, I2 0.03, voltage ratio 1.92, current ratio 1.6, power efficiency 31.46%. Voltage level for 50, V1 we get 50.3, I1 we get 0.07, V2 we get 2.226, I2 we get 0.04, voltage ratio we get 1.89, current ratio 1.75, and the power efficiency 34.9. 70, voltage level for 70 is V1 we get 70.3, I1 we get 0.08, V2 we get 36.6, I2 we get 0.06, voltage ratio 1.92, current ratio 1.33, power efficiency 22.5%. For the 100 voltage level, V1 we get 100.3, I1 we get 0.11, V2 we get 52.9, I2 we get 0.08, and voltage ratio 1.92, current ratio 1.375, and the power efficiency is 23.1%. For the next slide, 1.5K ohm. For the voltage level 10, we get the V1 10.1, I1 we get 0.03, V2 we get 5.27, I2 we get 0. The voltage ratio is 1.91 volt, and the current ratio error, so the power efficiency also 0. For the 30 voltage level, the V1 we get 30.5, I1 we get 0.05, and V2 15.83, I2 we get 0 also, and the voltage ratio 1.92, so the current ratio also error, and the power efficiency also 0 because the error. So we will move to the voltage level 50, so V1 we get 50.5, I1 we get 0.06, V2 we get 26.62, I2 we get 0.02, voltage ratio 1.98, current ratio we get 3, power efficiency 17.5%. For the 70 voltage level, V1 we get 70.7, I1 0.07, V2 36.8, I2 0.03. Voltage ratio is 1.92. For the current ratio, 2.33. And the power efficiency is 22.3%. For the voltage level 100, we get the V1 101, I1 0.09, V2 52.6, I2 0.04. Voltage ratio 1.92, current ratio 2.25, and the power efficiency is 23.14%. So we will move to the analysis for experiment 4. Thank you for.
For analysis 4, the voltage ratio in experiment 4 is 2, in accordance with the formula NPNS. Based on the result obtained for the 220 ohm, the average ratio voltage is therefore 1.63. At 680 ohm is 1.92, and for 1.5 kilo ohm is 1.91. Thus, it can be concluded that all three findings for the voltage ratio have nearly approached the value obtained by applying the NP and S formula, which is 2. Therefore, when applying the transformer idea, the experiment is linearly correct. NP and S equal to VP Vs. The Cooper loss in the transformer increases together with the load's value, decreasing the transformer efficiency. The load is 220 is the most efficient transformer to use when compared to the other two because it has the lowest load value.
Okay. Thank you, my team member. This is the discussion for this lab. Okay, and in this experiment, we discovered the utilization of two transformers to establish a transformers ratio. We carry out 4 tests in this lab using the step up and step down procedures. The step up approach is used in experiment 1 and 2. We employ the step up method for experiment 3 and 4. According to the result, there are losses on these transformers, which is a drawback of these transformers. This transformer is therefore not optimal. We we got to have developed a transformer that was superior to the one we now have. Okay, next for the conclusion is the conclusion is the transformer is an electrical device that can trace voltage for current in a circuit while not affecting the total electrical power. This means it takes high voltage electricity with a small current and changes it into low voltage electricity with a large current, or vice versa. In in the case of a perfect transformer, the power going into the machinery is the same as the power coming out the other end. It's a device that convert alternating electrical energy from the voltage level into alternating electrical energy from another voltage level based on the electromagnetic induction phenomenon. Finally, these ideal transformers are very important to use mostly in the power system. That's all from us. Thank you, and Assalamualaikum warahmatullahi wabarakatuh.